Hi students, now in this video we will discuss about the electrode potential. As I said earlier that if you have two different electrodes, suppose we have a zinc electrode and the zinc electrode is present in a zinc sulfate solution containing its own ions, a metal rod in contact with its own ions, and then you have a copper rod in contact with this copper sulfate solution, right, dipped in a copper sulfate solution. So as soon as you connect the two electrodes here through the wire, we find that electrons start flowing from the zinc to the copper. So which means zinc electrode loses electrons and the copper gains. So that means zinc undergoes oxidation here, okay, zinc undergoes oxidation and the copper undergoes reduction. Because the zinc changes into the zinc ions here. So when a zinc rod here dissolves, so what you get the zinc ions here. So the reaction is like this. So zinc ion changes into the zinc ions and the electrons start flowing through the wire towards the copper, where the copper actually ions, they gain the electrons and they actually gain the electrons from the copper solid. Now see, when the zinc loses electrons, so we can say here that zinc has a high tendency to lose electrons in comparison to the copper, right? So why zinc loses electrons? Because zinc has high tendency to lose the electrons. So it has a high urgency here, it has a high tendency for the loss of electron than the copper, and in comparison we can see the copper has a high tendency to gain the electron in comparison to the zinc. The electrode potential, what now is the electrode potential, right? Electrode potential is basically about the relative tendencies of these electrodes. So this electrode potential itself is a relative tendency where we measure the tendency of any electrode either to lose electron or to gain the electron, right? So term electrode potential by itself means the tendency of an electrode to lose or gain the electron. That means it is the tendency to get oxidized or to get reduced. When we connect here the zinc rod with the copper, we find the zinc undergoes oxidation and the copper undergoes reduction. So therefore we can say that zinc has high tendency to get oxidized, okay, it has a high tendency to get oxidized and the copper has a high tendency to get reduced. That's why the zinc loses electrons and the copper gains. And we know that this is a spontaneous process. As soon as you connect to the two electrodes, zinc starts losing electron and the copper gains. It's because the zinc has a high tendency to lose electron and the copper has a high tendency to gain electrons. Now this tendency of the electrodes to lose or gain the electron is called as electrode potential. Okay, so electrode potential is basically the tendency of any electrode either to lose electron, that means to undergo oxidation, or reduction, that means to gain the electron. And the magnitude of the electrode potentials will represent the relative tendencies. Okay, the magnitude of electrode represents the relative tendency of the electrodes to gain or lose electrons. So we can say that now electrode potential is basically the relative tendency of an electrode either to lose or gain the electrons. And now the factors which can affect the electrode potential. The three main important factors that determine the electrode potential. Number one is the nature of electrode, right? If you have a copper, the copper metal is different than the zinc, than the iron, because their nature is different, right? So that's the first factor. The second factor is the concentration of the ions in the solution. When you take any metal and you dissolve in the same in a solution containing its own ions, you get the electrode there. Now the electrode potential of this electrode depends on the concentration also here, right? The concentration, suppose you have a zinc rod, okay, and you dip a zinc rod in a zinc sulfate solution. Here we have a zinc rod in a zinc sulfate solution, okay. So this is the 2 plus and this is the 2 negative here, okay. So at different concentration, that means the zinc rod in a zinc sulfate solution at suppose 1 molar concentration and 2 molar concentration, right? Same electrode but different concentrations. At 1 molar concentration, the electrode potential will be different than at the 2 molar concentration. So that means if you change the concentration of the solution here, of this solution in which the particular metal rod is inserted, right, the electrode potential will also change. And later on we will discuss, how much it can change. We have an equation for that, that will actually tell us how much electrode potential will change. That is the Nernst equation. In the later in the later part of this chapter we'll discuss it there, the effect of concentration, how much actually the concentration can change, can alter the electrode potential. But right now we'll say that, simply remember that electrode potential, it also not only depends on the nature, it also depends on the concentration also, right? So if you change the concentration of an electrolyte here, okay, then the electrode potential of the electrode will also change. Similarly, temperature also has a important role. So by changing the temperature, for the same solution, suppose we have a zinc rod, suppose at a 1 molar concentration at 25 degrees Celsius, its electrode potential will be different than at the 50 degrees Celsius. So simply by changing the temperature, right, if you keep the concentration same and the nature of the electrode is the same, so suppose you take the zinc rod in the 1 molar 1 molar zinc sulfur solution at 25 and 50 degrees Celsius, the electrode potential will be different, okay. So that means temperature also affects the electrode potential. And then we will discuss, in the Nernst equation, as I said, that we are going to discuss the quantitative effect of the concentration and the temperature on the electrode potential. But right now we can simply remember that electrode potential, it depends on the nature of the electrode, depends on the concentration of the solution and temperature. If you change any of these, right, electrode potential will change. We also use the term standard electrode potential, right? What does the standard electrode potential represent? The standard term itself represents that if you keep the concentration of a solution 1 molar and temperature 25 degrees Celsius, right, 25 degrees Celsius, the electrode potential measured at a 1 molar concentration and 25 degrees Celsius, that is the standard electrode potential, correct? So if you want to find the standard electrode potential of a zinc, so I'll take the zinc rod and I will insert it in the 1 molar concentration solution, 1 molar zinc sulfate solution at 25 degrees Celsius. So that means electrode potential measured at 1 molar concentration and 25 degrees Celsius, that is the standard electrode potential. As discussed, that the electrode potential is the relative tendency of the electrodes, right? Electrode potential is it measures the relative tendency of an electrode either to lose electron or to gain the electron, right? So that means it is the tendency of an electrode to undergo oxidation or reduction. So accordingly we have two types of electrode potential, right? One is an oxidation potential, which means the tendency of an electrode to lose electron, and the reduction potential means the tendency to gain the electron, to accept the electron, right? So electrode potential, it's of two types, oxidation potential and reduction potential. As earlier discussed, that if you take the two electrodes, the zinc and the copper, we find the zinc acts as anode, it loses electron, and the copper acts as a cathode, it gains electron. So therefore we can get a conclusion here, the zinc loses electrons because it has a high tendency to lose electron, that means it has a high oxidation potential, right? It has a high oxidation potential. So the zinc has a high oxidation potential, it has a high urgency, high tendency to lose the electron, okay. So similarly the copper, it gains electron, so we can say that it has high tendency to gain the electron, that means it has high reduction potential. And an electrode which has high oxidation potential, obviously it will have a low reduction potential. So I can say the zinc has a low reduction potential, right? Okay, zinc has a high oxidation potential but low reduction potential. Okay, similarly copper, it has a high reduction potential, it has a high tendency to gain the electron, so we can see it has very low tendency to lose the electron. So I can say that it has a low oxidation potential. And we can interconvert. Suppose if you know the oxidation potential of an electrode, you can change it into this reduction potential simply by changing the sign, right? So that's how actually we change the oxidation potential into reduction potential. You know, if you know the reduction potential, you can change its sign, and you know the reduction potential will be negative of the oxidation potential, or you can say oxidation potential is negative of reduction potential. So that means if you know the oxidation potential of an electrode, right, so you can find its reduction potential. So how we measure this electrode potential, that we will discuss in the next video. You know how to measure the electrode potential. But my point here is that if you know the oxidation potential, if you know how much is the tendency of an electrode to lose electron, right, so you can find this reduction potential by changing the sign simply. Okay, suppose the zinc has a high tendency to lose electron, that means it has a high tendency to gain the electron. That means I can say the zinc here, suppose it has an oxidation potential of, for example, it is 0.76. okay, 0.76 volts. This is the tendency of the zinc electrode to lose the electron. So that means its oxidation potential is 0.76. So what will be the reduction potential for the same electrode, for the zinc? Simply changing the sign, negative of the 0.76. So minus 0.76 is the reduction potential of the zinc, while as plus 0.76 it is oxidation potential. So that's how actually we interconvert oxidation potential and reduction potential, simply by changing the signs only. Okay, suppose we have a copper, and copper we know it has a high reduction potential. Suppose the the reduction potential of the copper here is for example, if it is 0.34, okay, so therefore its oxidation potential, right, will be then minus 0.34. so negative, simply changing the sign, right. So simply changing the sign changes the oxidation potential of an electrode into reduction potential, and also the reduction potential changing into the oxidation potential, simply by changing the sign. So this is actually how we measure the electrode, how we interconvert oxidation potential into reduction potential and reduction potential into oxidation potential. Okay, so to conclude here, we can say that electrode potential is a measure of a relative tendency of the electrodes, right, to lose or gain electrons, and the tendency to lose the electron is called oxidation potential, and the tendency to gain the electron is called as reduction potential. So hope you got the concept. Thanks for watching the video. See you in the next lesson. Bye.